Here in this video, we introduce the concept of instantaneous center. We consider a rigid link AB, and that rigid link is having first translation motion from AB position to A1 and B dash position, and then it is having a rotation motion about the A1 point, and this B1 point reaches to B1 position. So in the first case, first it is having a translation motion and then it is having a rotation motion. In the second case, the same link AB we are considered. First it is having a rotational motion, then it reaches to the position A1 and B dash, and then it is having a translation motion. And final position is A1 and B1. The final position in both the cases is A1 and B1. In the first case, it is first having the translation motion and then the rotation motion. In the second case, first it is having the rotation motion and then it is having the translation motion. If the motion is so gradual of these links, then it is difficult to recognize whether translation is taking place first or rotation is taking place first. But it seems that the whole link is having a pure rotatory kind of motion about some center, and that center we are calling as the instantaneous center. In the second diagram, if we see, we have a link A1 and B1, and that link is after some interval of time changing its position from A1 B1 to A2 and B2 position. So we find out the instantaneous center. The one way, the velocity vectors at point A1 is in this direction and the velocity vector of B1 is in this direction. So we draw the perpendicular lines from this velocity vector and they are meeting at point I1. So this is the velocity vector here and this is a perpendicular line, and this line is A1 I1, and from B1 velocity vector again we draw a line perpendicular, that is B1 I1. So these two lines are meeting at I1. So I1 is called the instantaneous center of this link A1 and B1 at that instant. Means it seems that the whole link is having a rotatory kind of motion about that center. If after some interval of time the new position is A2 and B2 and the velocity vectors at this point is in this direction and the velocity vector at that point B2 is in this direction. So again we draw the perpendiculars from these two velocity vectors and they are meeting at point I2. So we see that as the link is moving from A1 B1 position to A2 B2 position, the instantaneous changing is position from I1 to I2 position. So the locus of such a instantaneous centers I1, I2 and then further I3 and I4 is called the space centroid. If we are considering the C1 point with respect to the link A1 and B1, so this is also changing its position from C1 to C2. So when A1 B1 position is there, then this point having the C1 point, and then when the link is changing its position to A2 B2 position, then it is having a C2. So the C1 and C2 point is also changing with respect to the link basically, and this the locus of such points C1 C2 and C3 are called the body centroid. Here we see how to find out the velocity of any of the point on the rigid link with the instantaneous center method. So here we are considering a rigid link. In the first diagram it is shown a rigid link and there are 2 points on the rigid link A, B. Rigid link means the distance between these 2 points are not changing if we apply some force on the linkages. So this means that this is treating as a rigid link. So the velocity of this A point is V. This is the absolute velocity of this point A, and this direction is alpha with respect to AB. Similarly, the B point having a velocity VB, and the angle with respect to AB is beta. So here the VA is known to us in magnitude and direction, and VB is known to us only in direction. We do not know the magnitude of this vector. So let us see how to find out this VB value or the velocity of any other point C on the same linkage using instantaneous center method. As we discussed, first we draw a line perpendicular to this VA vector, and this line is supposed to say AI. Similarly, this velocity vector directions we know VB, so we draw a line perpendicular to this VB vector, and these two lines are meeting at point I. So this I is the instantaneous center about which it seems that the whole link is having a pure rotatory kind of motion. Now we know that this link is a rigid link and they are having this point A and B or any other point on the link having same angular speed omega. So we know that V is equal to R into omega, or omega the angular speed should be equal to velocity upon the distance from the center of rotation or from the instantaneous center. So the omega should be equal to VA upon AI, with the velocity of this point A and into AI the distance of this point from the instantaneous center. So this is VA over AI. Similarly, the velocity of this B point is VB divided by BI. So with this relationship, because VA we know, and then the distances we have measured this AI and BI, and then we can find the value of the VB from this relation. If we have some other point C on the link, so what we do, we join this C point with the instantaneous center, and we draw a vector perpendicular to this IC line, and this representing the velocity of this C point also. So this way we can see that we have any other point on the same link. So how to find out the velocity of that point here? So again, this C point is also having same omega, so same angular speed. So this is VC divided by CI. So we can measure the value of CI, and we can find out the value of VC of any other point on the same link. So this way we see that how to find out the velocity of any of the point using instantaneous center method. Now here the second figure, there is a formula to find out the number of instantaneous center in any of the mechanism. So here this is a 4-bar mechanism, because the link number 1 is fixed here, and there are 4 link number 1, link number 2, link number 3, and link number 4. So we can using this relationship we can find out the number of instantaneous center, where n is the number of instantaneous center, small n is the number of linkages. So here we put the value of n is 4, because this is a 4-bar chain here, and 4 into 3 divided by 2, so we are getting 6. So there are total 6 instantaneous center in this 4-bar mechanism. So now how to designate the instantaneous center? There should be a specific way. If the links are pin joint, if link and 1 and 2 are pin joint at the spin connection here, so we are the instantaneous center of these two links are representing by I12. I means the instantaneous center, and 1 and 2 link 1 and 2 link. The first digit shows the first link, and the second will show the second link. So first is the lower digit and then the higher one. So 1 2. Similarly, if we have the link 1 and 4, so the instantaneous center will be at point A, pin point A, and that is I14. Similarly for 3 4, that is I34, and similarly this is 2 3, they are pin joint at this C point, so this is I23. So, and there are two ICs which are lies outside. I will tell you how to locate this IC later on. And this IC is I24, and this IC is I13 basically. So if we see, there are total 6 ICs we have located for this 4-bar chain, and there are 3 different category of IC. First we are calling as a fixed ICs, fixed instantaneous center. So here I12 and I14 are the fixed instantaneous center, because they are fixed in the mechanism. They are not moving with the mechanism. Then the I23 and I34, they are called the permanent ICs, although they move as the mechanism move, but they remain at their position. So this is called the permanent ICs. The third ICs are neither fixed nor permanent. The IC13 and the IC24 are the called as the neither fixed and nor permanent ICs, because these ICs changes with the as we changes the configuration of the mechanism. So this way we see that using this formula how to find out the number of ICs in any of the mechanism. There are certain cases to whom we should know the IC before locating the IC of any of the mechanism. So here first we have the link. There are two links. The first case link 1 and link 2, and these two links are pin joined at the pin connection here. So when the two links are pin joined, so their IC lie at the pin connection. So this is I12. When we have a disk and that disk is rolling on a plane surface, so their ICs lie at the point of contact. So here we see that the point, this is point of contact, so this is I12. And if we want to locate, there are 2 points A and B, and if you want to locate the velocity of these two vectors, so we can join this A point with I12, and because the rotation is in the anticlockwise direction, so we represent the velocity vector VA, which is perpendicular to this A I12 line and in the anticlockwise direction, in this direction basically, so that it have a sense of rotation in the anticlockwise direction. Similarly for point B also, if we have a slider kind of linkages and that is sliding on a fixed link 1, so their instantaneous center lie at the infinite, because here VA is the velocity of this point and VB is the velocity of this point. So if we see, if we know that if we are locating the IC of any of the point, we draw a line which is perpendicular to VA vector, and that is meeting here. This is that line. Similarly at VB velocity vector, we can draw a line perpendicular to this VB vector, and this is again meeting at the. So we see that these two lines are meeting at the infinite. So when there is a slider kind of mechanism, okay, then the IC lie at the infinite, and in that situation the velocity of any point on the slider VA and VB is same. If we have a link 1 and then the other link slider is sliding inside that fixed link which is in the curvature form, so their ICs lies at the center of curvature of the link 1 or the fixed link basically. So this is the center of the curvature of the curved surface. So their IC I12 lies here basically. And if we are having 2 points again, A and B, and we want to find the velocity of these 2 points, so we can join this I12 with B point and I12 with A point, and then because this is slider is moving in the clockwise direction, so this is the sense of velocity in the same direction. Similarly, if we have a link 1 and the link 2 is having a slider which is sliding over that surface, so there instantaneous center lie at the center of the curvature basically. This is I12, and again if we have 2 point 1 and so A and B, and if you want to represent the velocity of these 2 points, we join this AB point with this instantaneous center, and because this slider is moving in the anti-clockwise direction, so the velocity is also having the same sense, and that is perpendicular to the line joining to that point with uh, instantaneous center. Very important theorem called the Kennedy theorem or three center inline theorem. It says that when we have the three links and then these three links move related to each other, so their ICs lie in the same line basically. So let us also prove this. So suppose here we use the formula n is equal to n into n minus 1 upon 2 to find the number of ICs here. The small n value is 3 here in this case. That is 3 into 3 divided by half, that will come out to be 3. So there are 3 ICs. So link number A and B are pin joined, so their ICs lie at here the pin connection. This is IAB. Similarly, A and C, this is the IAC here, and this B and C are links are pin joined at this point. So this is IBC. Suppose we are considering this point, this intersection point, IBC, say on the link number B, and it is having a rotation in the anti-clockwise direction. So the velocity vector, this VBC will be perpendicular to this one and having an anti-clockwise sense basically. Similarly, if this point we are considering on the right link, suppose on C link, and this link is moving suppose in the clockwise direction, so the velocity vector of this point is also in the perpendicular to line joining IBC and IAC, and having a velocity sense which make the rotation of this link into the clockwise direction. So this is the velocity vector. So same point in any of the mechanism having two velocity vectors and which are different, which is this is not possible. Any point on any of the link having same velocity with respect to any of the point basically. So this is only possible when this IBC point will lie on the line joining IAB and IAC. If suppose this point is somewhere here, so the velocity vector with respect to which this will be in the vertical direction, upward direction, and I with respect to IAC, this is also having a velocity vector into the perpendicular direction. So when this point IBC will lie on IAB and IAC, when only in that situation the velocity vector having this intersection point IBC having the same velocity vector. So this is the Kennedy theorem. Means when there are three-digit links and they are moving with respect to each other, so their instantaneous centers lie at the in the same line. In the previous slide, we have discussed that there are 6 instantaneous centers for a 4-bar chain. Now, here we see how to locate all these ICs basically. So, there are 4 linkage 1, 2, 3, and 4. If we use this formula, n is equal to n into n minus 1 by 2, 6. So, there are 6 number of ICs. So, first of all, we see all the possible combination of ICs. So, on the first row, we will representing the links here. So, there are 4 linkages 1, 2, 3, and 4. So, all the 4 links we have written. If there are 6 linkages, so we can write down up to 5 and 6 here. Then we see all the combinations. So there are instances. So first combination is there should not be any self combination. Means we don't have I11. We have the combination I with 2. The link I and 1 and 2 having the pin connection. So there is a possible combination of I12. So I can be having a you can say connection with 2. The first link having connection with 3. Then first link is having connection with 4. So I12 we can write down here, then I13 we can write down here, then I14. If we move to the 2, so 2 is also having the you can say connection with 3. So this is I23. So I23 we can write down here, then I24 we can write down here. I21 and I12 already we have mentioned it here, so there is no need to introduce it again here. Similarly, if we have the 3 can have the possibility with 4, so this is 3 4. If we count these ICs are 6 in number basically. This is I12, I13, I14, I23, I24 and I34. All the 6 ICs we have to locate in the problem. Now we see that we have already discussed that when the link is having a pin connection, so 1 and 2 is having a pin connection, so there I12 lies at the pin joint. Similarly 2 3 having the pin connection, so their IC is light as I23. Similarly 3 4 having pin connection, so their IC is light at 3 4. Similarly I14 having a pin connection, so their IC is light at I14. So here out of these 6 ICs or 4 ICs already we have located easily without with the basic knowledge only. Only these 2 ICs, that is I24 and this I13 only we have to locate. Now how to locate this IC? We are using a circle method to locate this. So there are 4 linkages. So 4 points we are marking on the circle, on the periphery of circle. This is point number 1 on the periphery. This is point number 2. This is point number 3. This is point number 4. This joining, the line joining 1 to 2 will represent the I12, IC12. Then similarly, line joining 2 to 3 representing the IC I23. Similarly, I34 and then similarly I14. So line joining with these 2 points representing their ICs basically. Now this we join this I12, then we join 2 3, then we join 3 4 and we join 4 1. So these lines are solid lines because these ICs we know and already we have located these ICs. I12 already we have located here. Okay. Then I23, this is I23 again already we have located in this one. Then 3 4, this is solid line, this is already we have located. Similarly I14 already we have located here, this is the IC I14. Now these two IC I13 and I24 we have to locate basically. So I13 means we join this point 1 with 3. So this is the IC I13 and I24 we join this 2 with 4 by a dotted line. So this representing the I24. So the IC which already we have located easily in the mechanism, we representing there by the solid lines, and the IC into which we have to locate. Okay, then these ICs we are joining with the dotted line. So I13 and I24 we are joining with the dotted lines. Now if we see that, then we have to see that this, suppose first we are locating the IC I13. So to locate this I13 we have to see the, then this line is the common side of the two triangles I123 and I143. This 1 3 we see that it is the common side of these two triangles. So it is the common side of triangle 1 2 3 and triangle 1 4 3. It means this I13 will lies the line joining I12 to 3, the intersection of I12 to 3 and I14 and 3 4. Means we are making a line joining I12. So this is I12 here and I23 and this is I23. So we extend this line here. Clear? Then if we see the lower one, the lower triangle is I1 4 and 3. So I1 4 3 means we are again making a line joining I14 and I34. So this is I14 and this is I34. We extend this line here. Where these two lines are intersecting, there we are getting I13. So this way we are locating I13 here. Similarly, if we want to locate the I24, so this I24 is the common side of the two triangles 1 4 2 and 2 3 4. So this IC24 lies at the intersection of line joining IC 1 2 1 4 and 3 4 and 2 3 basically. So let us see this I24. So this is I12, this is IC I12 and the second side of the triangle is 1 4. So 1 4 we extend this line here, line joining I14 and I12. So we extend this line is somewhere here, extending somewhere here, and then the 2 3 and 3 4 line joining I23 and 3 4. So this is I23 and this is I34. So we again extend this line. So these two lines we see that they are meeting at this intersection point, and this IC is I24. So this way we have to see that by using the circle method, if there are 6 number of points, so we are all locating 6 points on the peripheral circuits, and then we see we join the points with the solid lines whose IC already we have easily located using the previous slide, and we see the ICs to whom we have to locate, and we can join them by a dotted line, and we see that these dotted lines are the common side of which two triangle. This normally we have to see, and then this way by using this method of circle we can locate the other ICs in any of the mechanism. So here we solve a numerical problem using IC method, and we have to find the velocity of the slider and the angular velocity of the connecting rod. So this is the actual problem. We have a single slider crankchain in which we have 3 turning pair and 1 sliding pair. So here this OB is the crank whose length is 100 mm, and this is making an angle 45 degree with the AO line, and this AB is the connecting rod whose length is 400 mm, and this A is the slider in this case here, and this is again the fixed link. The omega angular speed of the crank BO is 10 radian per second in the clockwise direction. This is the actual problem. So first of all we have to number the different links. So we start from the right side. So fixed link number as 1, then crank BO is number as 2, then AB with connecting rod number as 3, then slider as link number 4, and then again the fixed link number as 1. So wherever in the mechanism we have the fixed link, we number them same. So here we see that we have the one fixed link here, and then we have the fixed link here also. So we number them same basically. Now we have to find the number of ICs using the formula capital N should be equal to N into N minus 1 divided by half. There are 4 linkages, so we put N is equal to small n is equal to 4 here, so we got the value of 6. So there are total 6 ICs in this single slider crankchain, and in the next slide we have to see how to locate all the 6 ICs and how to find out the velocity of the slider and angular velocity of the connecting rod. So first we have to see the naming of the IC, and for this we have to make this table as already we have discussed. There are 4 number of links. So in the first row we show the links, that is 1, 2, 3 and 4. Then we see all the possible combination. So 1, 2 is the one combination, then 1, 3 and then 1, 4. We write down 1, 2, 1, 3 and 1, 4. Then we start with 2, then 2, 3 and 2, 4. So this is 2, 3 and 2, 4, and then 3, 4. So this is the 3, 4 only. Okay, there is no self combination of the linkages. Now after this we have to see that as per the discussed in the previous slide, which IC easily we can locate, because if there should be some slider, so the IC slider the infinite, if there should be a pin joint, the IC slider the pin connection. So here let us see that this this is 1 and 2 are the pin connection here. So there I12 lies here. This is I12. Then this is 2, 3 are having pin joint at point B. So this is I23. We can locate easily here. Then 3 and 4 is again having a pin joint. So this is I34. Okay. Then 4 and 1. This is the this slider is the link number 4, and this is the fixed number. So I14. 4 here is a slider A, and then 1 is the fixed link. So this is the combination of 1, 4 is making a sliding pair. So when there should be a sliding pair, so their IC is at the infinite. So we have located the I14 at the infinite. So this is the I14 basically. Okay. So this way easily we have located I12, then I23, then I34, then I14. So these 4 IC easily we have located. Now the IC which are still remaining, we join them with the dotted line. So I12, okay, then I23, I34, then I14. So I13 and I24 now we have to locate. So we can join the line joining by 1 and 3. So we the circle method. All the 4 points we have to locate on the periphery, because there are 4 linkages. Join 1 to 2 because we know we already located this IC. Then join 2 to 3. Already we located this IC. Then 3 to 4 and then 4 to 1. Okay, these are the solid lines. Now I13 want to locate, so we join this I123 here. Now this is by the dotted lines because we have to locate this IC into the problem. Now we see that this I13 is the common side of two triangle I1 1 2 3 and then 1 4 3. So means this I13 lies at the intersection of line joining ICs I12 to 3 and I14 and 34. So I12 is here, then I23 is here, we extend this line. Okay, then I34 is here, and then I14 is the infinite. So this is the line joining I34 and I14. Okay, this is that line basically. Okay, now wherever these two lines are meeting, so there we are getting I13. This is the I13. So this way we can locate the I13. Now we have to locate the I24 next. So we join the points 2 to 4 by a dotted line, and we see that this 2 4 is the common side of the two triangles joining 2 3 4 and 4 1 2 basically. So this I24 lies at the intersection of line joining 2 3 3 4 and then 1 2 and 1 4. So here we have the 1 2, and this 1 4 is here. This because this 1 4 is at the infinite, so we can shift anywhere this I14 anywhere in any of the mechanism of any of the pin connection. So here we see that this I4 will be here, so we can shift it to here also, because infinite is the infinite, so anywhere we can shift this. So this is I14. So line joining 1 2 and 1 4. So this is the line joining 1 2 and 1 4. So this is 1 2 and sorry, this is yeah. So this 2 4 lies at the 1 2 and 1 4. So this is 1 2 and this is 1 4, and then 2 3 and 3 4. So this is 2 3 and this is 3 4. So we extend this line here, so we are getting I24 here in this case. So this way we have to see that all the 4 ICs normally we have to locate basically. Now we have to find the velocity of the slider A. Velocity of the slider A basically. So to find out, because this is a graphical method, so we have to this all the circles and table we have to draw on the copy, and this table will give an idea about the combination of the different ICs, and this circular method will tell you okay, which two lines we have to join, okay, to get the required ICs. And this diagram, this first one, you have to draw the graphically. Okay, so first of all you have to draw this basic mechanism, so all the numbering on them one, and then with the help of this drawing instrument you have to using pencil and scales and other instrumentation, you have to draw these lines graphically basically, and then you can measure them. So you have to measure I13 and A. So I13 and A you have to measure to locate the velocity of this point. We have to see that, because there are a number of ICs, so we have to see which IC we have to consider. So to find out the velocity of this slider, this I13 we have to consider, because that IC is related to slider basically. So we can measure I13 and A distance. As already we have discussed, this is a graphical method, so we have to measure this I13 and A. So I13 and A is coming out to be 0.56 meter. Now if you want to find out the value of the I omega A, so I omega A means we have to find the velocity omega of the link number 3, means this is connecting rod basically. So this is the velocity of the slider, VA divided by I13A. So VA divided by I13A, because this IC I13 is belongs to this slider as well as this link 3. So this VA divided by I13A is the omega of the AB, and this is also, if you want to find the velocity of this point B, this is also related to the point B basically. So this is VB upon I13B. So VB upon I13. So we join I13B and draw a line perpendicular to this one. So this is the velocity of this B point here. So VA, because VB already we know. How to know the VB? Because we know this value of crank length, we know this is 100 mm, and we know the omega, so that means the absolute velocity of this B point we know, VB is equal to R into omega. R means OB is 100 into omega is 2 and pi by 60. The RPM is given here at 10 radian per second, or directly the value of omega is given here 10 per second, so we can get the value of VB. So with this relationship, VB value we know, then I13B we have measured, I13A we have measured, then we got the value of VA. So VA is coming out to be 0.82 meter per second. Okay, by getting this value of VBA, we get the value of omega AB. So very carefully we have to select the ICs which are related to the different points and links, to whom the velocity or angular speed of the any of the linkage we have to find out. So here, to find the value of omega AB and velocity of the slider, we have to we have to choose the IC I13, because this ICs belongs to both the linkages. Thanks for watching this video on instantaneous center method. If you understand the complete video, then please like, subscribe and share. And it is also requested to see this video till end to get the complete idea or complete to understand the complete concept of instantaneous center method.